Alright, welcome to the E.D.D assembly video. So in this video I'm going to go through essentially the start to finish assembly for the E.D.D or entry denial device. Internally it's exactly the same as the E.D.H, which is just your entry denial holster that uses the AAP-01 Airsoft pistol, which I think will probably be more popular as a lot of people have those pistols and not many people use the Cam 70 shells. But either way, they're the same inside. I'll have a detailed list of all the parts in the download folder, which is on the Indiegogo campaign, or Colt's potentially in the future, the Colt's 3D website. But to briefly just go over some of the things that you will need in the components. Of course you have all the 3D printed items and then the main motor. This is 12 volt automatic car locking motor, or car door lock motor, which has a gearbox in there and it ended up being perfect for this project. You've got your IR laser, a little switch with an LED light or no LED light, a battery holder for two 18650 batteries, a little 5 volt relay, 3 M3 bolts that are either 30mm or 25mm, a single rivet which you'll use as your firing pin, some glue. This is a mini 360 voltage regulator. You'll need a lighter, some heat shrink, soldering iron, solder, some little connectors are preferable, but you can just use solder instead. You will need a black vivid multimeter for calibrating your voltage regulator, but I'll get to why you might not need that in future iterations. Pliers, a pocket knife, and any of the other accessories that you want to bolt onto it. So we'll open up and see what one actually looks like. So this is the E.D.H, but as I said, same on the inside. So you take the cover off, and that is what you were greeted with. And so you can see it's all kind of laid out and a little bit of glue added on the wires, so it all sits in there quite snug. And then you just hit the switch to turn it on and it's ready to go. So the IR laser just detects, well, it works as a brake beam, so it just detects anything that breaks the laser beam up to a distance of about 80 centimeters, and then that fires, trips the relay, which fires the motor. And that just sends a firing pin. See if we can get this out. There we go. A firing pin which activates the shell or fires the pistol trigger. No idea how long this is going to take, despite having built quite a few of them. I usually just put on some music and work away at it, but I think about 2 hours would be a good time frame to build one of these. Alright, let's get started. I will fast forward a lot of it and skip things that you don't need to know, but this is more of a breakdown to really give you a step-by-step guide. So first thing is, once you've got all the printed parts, remove any support material and clean up any whiffs on it, and then we'll put the motor in. This is probably the part that needs the most modification and the most time consuming, apart from actually connecting all the wires. First thing we'll do is remove this little rubber cover. We do not need that. Anything we cut off this, we're throwing in the trash. Just get pliers or snips and just cut the end off at an arbitrary length. Remove that in bin too. Alright, little hacksaw. You can use a Dremel or something, it's probably going to be a lot better, but I really want to show you how easy it is to do this assembly, and you don't need the best tools or anything really expensive. As I mentioned in the listing, a lot of this stuff you can get on AliExpress or Amazon for, it cost me about, I think it was 35-40 New Zealand dollars, so that's maybe $20 USD. So if anything breaks, you can easily just replace it for a couple dollars. The first modification you'll do to this, apart from snipping off the front end, is cutting with a hacksaw all the way around here, because we want to remove that front section of the plastic. Be careful not to cut in to the main firing pin or firing shaft, as we do need to keep that in. go, that can be binned too, as well as that. Alright, so we've made a little mark on the actual pinion gear, but that doesn't matter. As long as it's still all in one piece, that is fine. And so that's your rack and pinion gear, and then your motor sitting here. Next, what we want to do is, you'll see a small lip here. You want to cut at that point with the hacksaw. So I'll just check you can actually see that. A tiny little lip. Right about there. Does get a bit messy. Alright, perfect. Now, let's clean it up a bit with the knife. Perfect. Now the next thing we want to do is remove part of this section, because it's a clamshell design, so it's made in two pieces, and there's a seam all the way around the middle. What we want to do is cut in line with this, down and halfway down to that seam, well, all the way down to that seam, and then do that on one side and then all the way down on the other, and then I'll show you how we break the rest out. You can't cut too deep as you'll go into the gears, so just be careful with the depth of your cut. Alright, let's check you can see that. Down to the seam, more or less, and all the way round to that corner. Now, this one's a little difficult, but we want to get a knife and try and break the seal. Just try and... There you go. Being careful not to cut yourself. Side. There we go. There we go, we just break that off. Pull out that rubber seal. This part can be binned. Alright. Now what we want to do is remove all this internal structure. So I'm just going to put a little nick. So I've just realised I can only record in 10-minute sections on my phone, so there was some of that we missed. What I've just done is removed a section of the base, joining that corner where we cut to all the way up to about halfway up on that face. And what I did was just grab the pliers and snap that off. I'd also like to mention that being careful with your cutting distance with a hacksaw is you don't want to cut these wires. I mean, worst case scenario, you can just buy another motor. They usually come in 4-packs as well, so it's not really a big expense, maybe $5 for another one of these. Most of the work is actually just modifying it. Alright, next what we want to do is remove a section of this motor housing, which you might be able to see that I've drawn some lines going down and across. That's because there's going to be a lot of wires overlapping the housing, and the lid or the E.D.D or the cover needs to sit flush with this line here. So we just need to take out that square. There is better tools for this than what I'm about to do, but I'm just going to show you how you can easily do it with a hacksaw and a knife. I recommend just getting a Dremel with a tiny cutting wheel and just cut the square out. Again, this is an arbitrary cut. It doesn't really matter as long as it's wide enough for several wires to run across the motor. So try not cut too deep again, as there's a motor right under here and we don't want to damage that. Alright, now that we've made a mess everywhere, next I'm just going to score with the knife. And just do that 2 or 3 times. Here we go. Right, see that side's done. And we'll just score along the other side now. Let's try and score a straight line. Not that it matters, as all this is going to be covered and we will never have to look at it. Break that, and the motor's underneath. Now we should probably clean this up slightly. That side's already quite clean. It is quite soft plastic because it's from China. Perfect, and so when we put wires over, you can see that it sits flush. Alright, now there's only a few more things we need to do to this. Mainly we'll clean up this end a little bit. We then have to square out this area, as there is a printed part that I don't have. I will go get that. This bit, with a little bit of movie magic, it has appeared. This is the part that we need to place over here, and it actually enters the housing a little bit. So we need to drill a hole, a 2mm hole through here for your firing pin, and then do some modification around here. So what we need to do, I forgot, you only need to square out the top half. So that's where this little arch is. We'll just get our knife and see what we can do. And I do apologise if it goes out of focus. I can't actually see what the camera sees at the moment. Alright, let's see if that looks not quite. You can see it needs to enter through there. So I think we need to take out that section. Alright, let's see if you can see that. So it looks a little bit like that. Suppose it goes that way. Push that out. Alright, that looks good. Now, China being China, do not make these all the same. So depending on where you get them from, this black section will be slightly different. And how this is held on is 1, glue, and 2, there's a tiny lip under here which just catches on under this section, except that's completely flat. In this version, if you have a grey model, there's a lip that it hooks under. So what we need to do is then just carve out a section under here past that flat face. So we'll see if I can show you. Or you just break the lip off and use a lot of glue. Either way, I'm sure it'll work fine. Do we need to break off the sides? Yes. Oh, lovely. Okay. Let's see if I can show you that. So it goes along the flat and then dips down in there, and that is what that lip catches on. But there's one more thing we need to do for that, is drill a 2mm hole through the centre of that down to the exit of that. So you will need a drill and a 2mm drill bit, and then just try and do it as centred as possible and as straight as possible. Perfect. And that is where your firing pin will enter, which is half of that. Alright, what we'll do is add a whole heap of glue around here and hook it on, and that'll lock in place. So this is essentially just your manual release for your E.D.D, which is that component there. So if we turn it on, depending how it's made and part to part, sometimes it will bounce back, but sometimes it will not. And so to unload it, you need to push that back, and you can put in a new shell. While I'm here, some differences from the downloaded version versus the section that or parts I'm shipping out is that hole is for the flash indicator or the firing indicator, which you can kind of see on camera. There we go. And that is for tuning the range without taking the lid off, but China being China, don't make all the parts the same, so that didn't work for the next batch of sensors that I purchased. So we're just getting rid of that. All the ones I made, I set the range to 80 centimeters, as that works well for windows, doorways, corridors, that kind of thing. But you can reduce it down to about 3 centimeters for whatever reason, which is just that screw there. Alright, let's do some gluing. Hopefully your glue is a lot better than mine, as this is very old and goopy. But any Gorilla Glue or Super Glue will be fine. Yeah, that's terrible. Go off to the side for now. And what we'll do, you'll feel it click over, and then just push it in and hold it there until the glue has dried. Make sure it's kind of square. And I'll see you when the glue is dried. On second thought, while that is drying, we can also put in your firing pin, which I mentioned earlier is half of this. What we want to do is trim the mandrel on this rivet so that it just comes out to the edge of that, which I don't have the measurement, but we're just going to eyeball it. Take your pliers or favourite cutting tool. Perfect. Grab your glue. This is terrible. But it works, and that's all that matters. And so that just goes through there, push it in as far as it can go, and leave it there. So that ends up being your firing pin. And I believe that's all the work we need to do on the motor at this stage, so we can put that off to the side for now. Let's do some assembly work on the main body. The easiest part is probably installing the battery case. So the batteries are inserted through the back, and there is a battery cover. So we want to take our battery holder, flip it upside down with the wires pointing towards the left hand side, and then just push that down. And so you can see where the battery cover will go over it, but we'll leave this off for now. So push that flat. Alright, I guess it's time to do some wiring, which is always the most annoying part. There's no software in this is purely electromechanical, so we don't need any coding or anything like that. It's more or less just plug and play. There's just a few wires we need to plug in. I suppose we can do the relay first. So your relay, 5-volt activation, pretty standard and quite cheap, only a couple bucks for those. So that just fits in there. Depending on the relay, sometimes it should fit down slightly more than this, but China. But that just clips in, like so. And then what we want to do is start wiring up these 3 pins here. I'll show you the wiring diagram. I'll put it up on screen now. Essentially, you want to print this off or have it on your phone, somewhere where you can access it very readily. Because even now I've built heaps of these and I still have to look back at the wiring diagram to know what's going on. So, this, as mentioned before, is your sensor. So let's mount this on top of the battery case. It used to have an indexing part, but they stopped making these symmetrically, buyer to buyer. So there is actually an indexing slot here where it locks in place in the right twist, which is very important. But now I have a different component, which is this, which we glue into place and then that locks it. So we want your sensor, you'll see there's 2 squares, we want them to be perfectly horizontal. This is important, otherwise it will detect the case as part of an obstruction and automatically trigger the relay as soon as you turn it on, which you don't want. Another thing you need to do is grab your black vivid and black out this section, which will be right in front of where the laser sits. I've found sometimes, especially if you use lighter colours, that it can detect this as an obstruction. But if you black it out with a vivid, the problem is solved. So let's just go over that a couple of times. That's all we need the vivid for. Perfect. Let's grab our glue again. Actually, we can trim this because we don't need the wires to be this long. We can keep this because this will help us wire up the rest of it, so you don't actually need to purchase any extra wires. This is your sensor. I had a really tough time figuring out which sensor to use and which version of each sensor, but finally figured it out, and this is what we settled on. It's quite a cheap sensor, it works quite well. We can get rid of the sticker, it is not needed. Now we can probably trim this even more. what would be better for this is some wire strip. I highly recommend a pair of these if you are building one of these. It makes the process so much easier. Now if we reference back to the wiring diagram, we can see that the black wire goes directly, which I've probably made slightly too short. Damn, oh well, that's not an issue. The black wire goes directly to the relay. This is your input, it's your signal wire. And then your blue goes to the ground, which is the middle wire on your relay, and the brown is your voltage wire, which goes to the left pin, the leftmost pin on your relay. The blue and the red also need supply from your Mini 360 voltage regulator, as this sensor runs off 5 volts and the rest of the system runs off unregulated 2-cell, which is, I guess, up to 8.4 volts. Alright, how do we want to do this? I say we just trim all the wires. You know what? It's already quite a mess, let's just make more of a mess. You can use solder to join these wires. I like to just twist them together with the other end of the wires and then put some heat shrink around it. Seems to work quite well. Alright, we'll twist these. Now what we can do is find some more wire. We'll cut that end off, which we're going to join from here to the relay, but also have a third wire coming off to the Mini 360, which is this. So all your joins happen around here. Just cut that at an arbitrary length. Alright, now we need to connect these 3 wires to these 3 pins, if you can see that, on the relay, which you'll be able to see your input, ground and voltage. Input being the signal. I like to use these connectors for this part as there's already pins. But you could solder directly to it. Using these connectors means I have to fold them into these tiny, I don't even know, connectors, whatever you would call them, which can be quite time consuming and is a little bit delicate. But I'll speed this part up, I'm sure. So we just take a small amount off each wire. Now there is a tool for this. I do not have said tool, so I just use some oversized pliers. I like to pre-bend one side. Let's see if we can see that. So one of those tabs, or one pair those tabs will squish the wire, and the other will squish the insulation of the wire. Cool, and that's what it should look like. I'll just do the other three and we can skip ahead. And there we go, all three are done. Now let's push them into this connector. Doesn't really matter which way, as long as the blue's in the middle. And you want the top of it facing the exposed holes. Push it in until it clicks, like so. Let's get the black one on the right hand side. Close enough, and the brown on the left hand side. Cool, there we go. Now we're also going to take off the insulation at the other end on each of these. Fantastic. Now we can plug this into the relay, making sure that the brown is on the leftmost side and the black on the right. There we go. We can fold those over a little bit. These two can actually be threaded through where your switch is going, so they will be trimmed later. Perfect. Now, I suppose there's nothing stopping us from putting our motor in. Now it's all coming together. Right, if we look back at the wiring diagram, we can see that one of the simplest wires is the blue wire connecting straight to the normally open on your relay, which translates to this wire from the motor connecting to the rightmost connection on that end of the relay. So we can probably just shorten these wires so that they are easier to work with. I remember that being sharper. There we go. Only knocked some things off the table. Alright, where were we? Blue wire connecting to the rightmost side, which we will want a Phillips screwdriver of some description. And we will, if I can get in there, undo that terminal and undo the middle terminal as well, which is the common, as we'll also be using that. Perfect. We can probably trim this one here. That is rubbish. we will try and connect this into the rightmost side. It took a little bit of work, but as you can see, it is now in there, and we're just pushing it down out of the way. Let's do some work on the sensor. So we'll take our glue it into place, making sure it's perfectly horizontal, and then gluing it to the back of the battery case as well. So we'll take our extra goopy glue. We also want to make sure that the indicator light is facing, how would be the best way to do it, we're sitting higher than the adjustment. So if we put this on, probably towards the back, make sure that it is perfectly horizontal. That's what it should look like, with your indicator light higher and closer towards the bottom of the E.D.D. So we can glue that there. So take some more glue. It doesn't need much as there's not much force on this, but it is nice if you have to take it off that everything stays in place. And then we just push that in place, and it sits on a little shelf there. So we'll just do one more check, and that looks pretty good. So we'll just hold this for a while. That's probably dry enough for us to continue. Now let's look at wiring up the switch. So that is this. It'll be a little different if you get one that doesn't have a light. There'll only be 2 terminals here, but since we've got the light, we'll have 3. So that'll be our ground, accessory, and our voltage input, or positive. So if we look back at the wiring diagram, we can see that the battery positive goes onto that right side, and then we'll have the battery negative on the ground, but also on that ground will be the green from the motor. And then the middle one, and there'll be a third one, the ground for your converter. The middle terminal will have a wire going directly to the common, which is the center terminal on the relay, and that common also connected to the positive side of your little converter. Now, it might be best if we trim these wires just a little bit so that it doesn't get too hectic. Yeah, that's alright. Too hectic inside the E.D.D. We'll also want to grab our off-cut wires from the infrared sensor, as this will work as our spare wiring connecting the switch to the voltage regulator, which we'll glue about there. So let's work out how much we need. Yeah, that looks good. We only need 2 wires, positive and a negative. So negative, that will be black. Let's use that one. And a positive can be red to stay common, not red, brown to stay common with the sensor. Alternatively, you can get... Oh, that's got wire coming out of it. There should still be enough wire for a good connection there. These ends that I'm doing a little short will be for the voltage regulator. So we'll twirl them around and then fold them over themselves. There we go, and black can be for your negative in, which it is labelled on the other side. So in negative is this one. Slightly too thick if we fold it over itself. Probably should have cut that a little shorter. Not to worry, we'll make it work. Negative in. We can just fold that around on itself. Let's rest that somewhere. Grab our soldering iron, which we prepared earlier. Let's see if we can. Probably not the best contact, but that's alright. Both the iron and the solder are quite crap. Only slightly better than my soldering skills. Now, brown, which on the diagram would be the yellow wire, goes into the buck positive in. There we go. That one is much better. Yeah, those wires are a bit too long. But that's alright. Just make sure they're not touching anything else. Perfect. Now, let's trim these ends in a kind of long length. Alright, so the negative in tees onto the green one, which we also need to trim. Strip these back too. This might look daunting to some, but it's just following a step-by-step process. It's not as scary as it looks, because there is no software involved. Alright, that's looking good. Now let's tie some of these together. Black and green. Which green, let's say, is negative from the motor. Will be in this instance. Alright, the two black wires can be tied in. two black wires will be tied into let me check. Is that right? Yes, negative black is the green. I know there is a simpler voltage regulator you can use for 5 volts, as that is quite common, but I use these for a bunch of other projects, so that's what I happen to use for this one. Which just means it gets a little annoying when you have to calibrate it, especially if you don't have a power supply. And the brown one connects to the accessory and common. The accessory being the middle switch, and the common being also the middle switch put on the regulator. So we may need some more wire, but not a whole lot. Let's strip that. Slightly shorter than that one. And the slightly shorter one we will double up on itself. And we'll thread it through and put it into the middle terminal. Alright, common, brown, common. And so the two brown wires we can now tie together. And these will connect to the accessory switch. Alright. Hopefully you can see what I'm doing. Now, let's wire this up. Let's do with the golden side, or brass looking side, on the left side of the E.D.D. We want to thread the brown one through the middle and fold it over. Perfect. Prop that up. Now let's add some solder. Now you have to be careful not to heat the terminal up too much, as it will melt the plastic of the switch and ruin the switch, which I've done before. Alright, that's not perfect, but it's definitely going to hold. Any more and I think we may damage the switch. Next up, let's do the grounds. recording stopped again, so we just missed that last bit where I heated the right hand side up slightly too much, and you can see that it's bent. So hopefully, if that will focus, hopefully the contact is still good. What we can do now is put some batteries in and see if it's going to work. So we'll take the batteries out of this one. We'll leave that in there so we don't lose it. Remember, these are 18650 batteries. Let's make sure that it's turned off. Well, we've got a light, which is good. That's a positive sign. Let's grab our multimeter, and we'll now need to calibrate our voltage regulator. Which really we need a few hands for. Let's put this onto voltage DC 20. Turn that on. 7.63 volts. Let's check. Yep, you can see that. Now there's a little Phillips screwdriver here, or Phillips screw here, that adjusts it, which is very sensitive and very small. Let's grab a small flathead. So we need to get this down to below 5, around 5. That is too small. There we go, that'll work. 2mm flathead. Try and do this in a way where you can see it. Alright, anti-clockwise doesn't do anything. Let's turn it in clockwise, and you'll see the voltage drop. Now we want below 5. 4.9 is perfect. 4.94. That will do, because the sensor runs off 5 volt, which you can probably do a little bit more and a little bit less. A little bit less is always safer, so you don't burn out the sensor. That is all you'll need the multimeter for. That's probably the most technical part. Some people like to put a dab of hot glue on the actual adjustment itself, so in vibrations it doesn't change its calibration. I don't, because I don't find it really happens at all. Switch feels a little bit funny. That's probably because that is bent, but that's alright. We can always bend it back later. Right, the next steps. We want to connect, I suppose, get some wires and connect the outputs, which will tee into the voltage positive for the relay, now that we've got 5 volts coming out, and the negative, the ground, which will be the blue wire. So let's grab 2 more wires. We want a brown wire too. Let's keep it all the same. Just so there's no confusion. It's probably hard enough to follow as it is. So what do we want? Brown wire and a blue wire. Perfect. So let's strip these again. short amount for one end and a long amount for the other. Jesus. Goddamn Chinese sensors. Let's twist those. Check that it's off. Yes. And then the blue wire will go into the negative output, which we can see negative output there. So we can push it through and fold it down. Perfect. I got the piece that fell. All right. Now, positive out. Again, I could have simplified a lot of this and used sensors that had a higher voltage range that they operated on, but I designed this 4 years ago, and a lot's changed since then. Basically, I could have kept designing this over and over again, reiterating, improving on it, but I had to draw the line somewhere. And that line was releasing the files so that other people could make these instead of me. Because shipping from New Zealand sucks. Alright, that might be all the soldering we need to do. That is way too short. That'll do. We'll twirl these around. Alright. No idea how long this video is yet. Probably too long. Let's do some things. Basically connect up the colours. This is the easy part. Let's make sure we get some heat shrink so that nothing is shorting out. So it looks like that, which means 3 in blue. That'll do. Actually, these are way too long as well. Probably only need half of that. So the black one is the easiest because the black wire from the relay connects up to the black wire from the IR sensor, which is kind of a relay in itself. Just twirl them around. Fold them over. And slide the insulation over. And then we'll heat them up at the end. Next is the glue. Which I think we might need bigger insulation. Bigger heat shrink. We'll see what we can do. Over there. Oh, it does. Nice. It's all coming together. Last is the brown wire, which should be the voltage positive. There we go. That's effectively finished in terms of the wiring. It looks messy, but let's see if it works. Hey, there we go. It works. One thing before I forget, the only sort of know-how of how this works that you need to know is that don't leave the E.D.D triggered for long periods of time, as the motor's not spinning and this will eventually burn out the motor. It is a 12 volt motor and it's only running at about 8 volts with the two 18650s, but it pays not to leave it triggered, quite literally. Alright, let's glue the voltage regulator in place and then buy some more glue. Jeez. Usually I use a hot glue gun for this step, but we'll see how this works. Let's wait for a bit. The super glue didn't work, so we're just going to use the hot glue instead. I do not know why that was such a weird colour, but I'm not going to talk about it. While that's drying, we can also use a lighter and shrink the heat shrink. Right, now let's push the switch in. There are indexing slots on this, so you can see one there and one on the other side which lines up with that slot. So when we push this in, it needs to be perfectly straight. Cool, it works. Now the last step on the inside is cable management. Which is more or less glue it all in place. So we could run a little bit of glue across here, kind of like this one, which just holds it down in place, making it easy to put the lid on. That is the weirdest colour glue. And we'll just let that dry. Now that that's dry, you can see you have it fully wired up. Next, let's put in the trim work. So the idea behind a lot of this was that you could change the colours for designated teams or objectives, however you play, and it also doubled up as being interchangeable parts for other accessories like these brackets. So it would slide in to the side and then you can screw it toward a tree or barrier or something if you have them permanently fixed in the field. But we won't be doing that, so we will take cosmetic trim and just insert them like so. So two of the screws for the cover, hold those ones in. These two, they are different lengths. Slide in like so, and are held in by the lid. Really they should be glued as well, but I generally just let them be held in by the lid. And then this one here is press fit. And you'll see there is a slight chamfer or angle, that bottom face, and that goes where my finger is pointing. So we just put it in like so, and that's your trim work. Now we can put on the lid, whether it be the standard E.D.D lid or the E.D.H lid. I won't be doing a separate video for this because it's pretty straightforward. You essentially print the locking mechanism, and I think I've lost it. I had the actual trigger for it somewhere. And then your release for the pistol. There's a separate part, which is now gone somewhere. Not to worry. We will just use the standard E.D.D lid, so we'll make sure that those are all pushed down flat, those are lined up. And then we just push it down like so, and then we put our screws in. I had to do a little modification off camera, which was just heat up a point there because it was hitting that light. As I mentioned, they change batch to batch as you get them from China, so if it doesn't fully sit flat, you may just have to apply some heat. So you can then squish it down so that it sits flush. Right. Now I guess we do the barrel. So choose the barrel you want. There's a whole bunch of them, different files that I'll put as part of the download. But we're just going to do the standard barrel, which can fire just about whatever you can load into the shell in terms of paint and airsoft. Depending on your field's rules and regulations, you may just want to run it as a sound mine, an acoustic trap, or use something like flour or some other powder that's not going to be dangerous. I'm not going to get into the blind fire bureaucratics of it all. That's up to you. I just design things. So we'll need to put in the magnet retention for this barrel. So we'll take 2 magnets, and the polarity is important for these. So we'll push one in like so, and then making sure that the polarity is right so that attracts. We will then push it in. Perhaps we remove this to make it easier on ourselves. Check the polarity. Yep. Actually, that may need some glue. Yep, that'll just need a dab of glue, depending on your printer and your settings. Might change the tolerances slightly. So that can dry there. And that'll be your magnetic retention. We can put this back on. Like so, and put some of the bolts in. Now I made a mistake earlier, I said 25 to 30 mil. It's actually 25 to 30 mil, but let's say 25 mil for these 3, and then the one underneath is 20 mil. So slightly shorter. So let's do 20, 25. Get the right fit. What is that doing there? Don't recommend using the drill, as it is just plastic. Or at least hand tighten it the last little bit. Alright, we'll leave that a little longer. The rear cover plate, that's fairly self-explanatory, but there's just a little lip underneath. And then you press it in place, and then you put a 20mm bolt through there. And if you want to get it undone, remove the cover plate. There is a small indentation there where you can fit a flathead and pry open the cover if you need to replace the batteries. When you're putting on the Claymore stand, if you're using that, you just have a slightly longer bolt. Actually, you probably use the same length bolt, 20mm, and you put it through there. And then that becomes your Claymore stand. We won't be doing that. And the pin through there acts as your magnetic retention with that magnet. I think the last thing before we put that in is put these magnets in. There's 10 of them. This helps you mount it to vehicles or barrels or anything metallic. It pays to make sure the polarity is the same on each of them, but it's not crucial. Sometimes you need to drill these holes out slightly with a 6mm bit. I like to put them in a little bit and then push them down. Further on the desk, these ones are much better. If I can stop bumping the camera, that would be great. I won't push them down all the way here, but you can also get a vise and squeeze them in that last little bit. But I don't need to show you that. Alright, the glue is probably dry, so we can put in the last bolt. Let's use the drill. Sometimes they're a bit difficult going in the first time. Alright, that bolt might be slightly too long. Yeah. So that's meant to be a 20mm bolt or 25. I'll swap that out later. But that's essentially all there is to it. That's your E.D.D. Put your shell in, channel on, and fire. And reload. The Indiegogo campaign will be up for another, I think, 2 days, 3 days. I may end up putting these on Colts. I don't think I'll do any more iterations of this. I've kind of left it for other people to modify if they so please, especially with the different covers, you know, for the AAP01 and other applications. Any questions, just ask down below, or go to the Facebook page. I'm sure all that will be in the links. Thanks for sticking it through for this long.